Okay, so this one here, we have a coefficient in front of the leading term. So what we want to do first is focus on the first two terms and factor out that leading coefficient. So that minus 30 just stays on the outside. We don't need to mess around with that. It's easier to deal with algebraically if we leave it on the outside. So now I have this piece that I'm trying to make square. Okay, so I'm just going to highlight this. I need to make this into a square. So to make this into a square, I have my x squared. I need to symmetrically distribute my 4x's. So minus 2 here, minus 2 here, and I need to then finish off that square. Okay, so at this point I have x squared minus 4x, that's what it looks like there. I need to make this a finished square or complete the square, so I get 4. So I'm going to put 4 in there to make it perfectly square. The problem now is this equation is not balanced, and this is one of the most important rules of algebra is balance. So I need to balance this. So what have I added on? I've added not just one 4, but this is important to keep track of that coefficient because I've added 5 positive 4s. So I need to balance that off with minus 20 on the same side. Okay, so once I've done that, this is all balanced. I can now write this as a completed square. This is very important because this completed square here identifies the middle of the vertex. Okay, so there's my graphing form. I now can identify the vertex. The vertex is at 2, negative 50. Okay, the axis symmetry at 2. So if I were to sketch this, 2, negative 50 somewhere way down there. I've got a y-intercept at negative 30. I can see that from my graph here. Draw a symmetrical point here. And I can sketch my parabola. Okay, in fact, I can find this coordinate very easily because using symmetry, I can find that coordinate there. Okay, so there it is. I got my completed square form, and again, this is the part that this is a square that I'm completing algebraically over here. So the last part here is that I have a vertex at negative 2, positive 5. I need to find k. So there's a number of different ways we can do this. Okay, so I could very easily do this. I can complete the square. Now that we know how to complete the square. So x squared plus 4x plus blank plus k. Okay, and I want to know what that k is going to be. Well, if I complete the square here, I'm going to end up with half of that squared is 4. I need to balance this with a minus 8. Okay, and if I write it into the completed square form, well, I've got, yeah, there it is. There's my plus 2, which becomes my minus 2 on my vertex. And I get k minus 8. Well, how does this help me? This helps me because that, I know, must be connected to the y coordinate of the vertex, because we know that these 2 points, these 2 values give us the values of the vertex. So if k minus 8 equals 5, then I know that k must be equal to 13. So there's my answer. Okay. So that's one way to do it. We can complete the square and relate this general form to its vertex form. There's a much easier way to do this, really, and it's to use that property that any x and y coordinate must be able to be fit back into the x and y in the equation. And if I do that, notice that there's only one variable left to solve for. So if I plug in y is 5, when x is negative 2, notice that I can just solve for k. So I get 5 is equal to 8 minus 16 plus k. Solving for k, it's 5 minus 8 plus 16, and I get k is equal to 13. Same solution. This one I think this one is a bit better because it just uses a simpler principle of the fact that we can always plug x and y back into the equation. However, we can relate this general form to a vertex form now, which allows us to make inferences about the vertex. And that's a very important process to be able to do, to be able to convert general form into vertex form.